So the positive and negative charge will form a bond. So this bond which is formed here is called as the hydrogen bond. And here also between nitrogen and hydrogen, one more hydrogen bond is formed. Alcohols are more polar than amines and form stronger intermolecular hydrogen bonds than amines due to their electronegativity difference. The observed basic strength of methylamine, dimethylamine and trimethylamine has been found to follow the expected order in gaseous phase. Hello everyone, this is Ambli Unnikrishnan from the Department of Chemistry. So today I am back with session 3 of the chapter Amines. So in the last session we have discussed the different methods of preparation of amines, right? So in today's session we are going to discuss the physical properties of amines. So we'll be discussing solubility, boiling point as well as the basic character of amines. So let us begin with the physical properties. The lower aliphatic amines are gases with fishy smells. The primary amines with 3 or more carbon atoms are liquid and higher members are solids. So the lower ones which is having 1 or 2 carbon atoms, they are generally gaseous in nature and they have a fishy smell, okay? And the ones which is having 3 or more carbon atoms, okay? 3 or more carbon atoms, they are liquids and the higher ones will be solids. Now regarding solubility, lower aliphatic amine means straight chain or branched amines are called as aliphatic amines. There won't be any ring structures, it's open structure, are water soluble because they can form hydrogen bonds. So why they are soluble in water? Because they are able to form hydrogen bonds with water molecules. However, the solubility decreases with increase in hydrophobic alkyl group. So regarding the solubility part, we have already discussed in the other organic chapters as well, right? When the alkyl group becomes bigger and bigger, what happens? The solubility decreases, right? And why any compound is able to form or get soluble in water is because of the formation of hydrogen bonds, right? So you can see OH, that is your H2O, right? And you have oxygen here and this is your amine. This is our NH2. So comparing this oxygen, hydrogen, so comparing here, you can see oxygen is having a partial negative charge and hydrogen is having a partial positive charge. Nitrogen is having a partial negative charge. So the positive and negative charge will form a bond. So this bond which is formed here is called as the hydrogen bond. And here also between nitrogen and hydrogen, one more hydrogen bond is formed. Even nitrogen is more electronegative than hydrogen. In that way also one bond will be formed here. So because of the formation of hydrogen bonds between the oxygen and hydrogen atom, oxygen of water molecule and hydrogen of the amine, there can be a hydrogen bond which is formed, right? Now aromatic amines, they are insoluble in water but soluble in ether, alcohols, etc. So alkyl amines or else aliphatic amines, they are soluble because of the formation of hydrogen bonds. But aromatic amines are generally insoluble. By considering the electronegativity of nitrogen of amine and oxygen of alcohol, we can predict the pattern of solubility of amines and alcohols in water. Alcohols are more polar than amines and form stronger intermolecular hydrogen bonds than amines due to their electronegativity difference. So, if I have an alcohol as well as an amine. Okay, you have an alcohol and amine. So here the electronegativity difference we are considering between oxygen and hydrogen. So oxygen is very high electronegative element. It is having high electronegativity. But comparing nitrogen and hydrogen, nitrogen is having more electronegativity but not to the extent which oxygen is having. So because if the element is more electronegative, then the bond becomes more polar, right? So considering OH and NH bond, OH bond will be more polar because oxygen is more electronegative than nitrogen. That is the reason why in alcohols the bond will be more polar, hence the alcohols will be more soluble in water compared to amines, okay? So comparing alcohols and amines, alcohols will be more soluble in water because the bond is more polar because oxygen is more electronegative. I hope it is clear. Now moving on to boiling points, all amines except the tertiary amines are capable of forming intermolecular hydrogen bonds due to the presence of polar nitrogen-hydrogen bonds. Okay, so there must be, that is hydrogen atom present in the amine so that the hydrogen bond can be formed. Okay, so in primary amine RNH2, you have 2 hydrogen atoms. Secondary amine, it is R2NH, you have one hydrogen atom. Tertiary amine is R3N. You don't have any hydrogen bond itself. So that means tertiary amines do not form intermolecular or intramolecular hydrogen bonds, right? The boiling points rise gradually with the increase of molecular mass. Of course, molecular mass increases means the molecule or the compound will be much more heavier. So it requires more boiling point, right? Yes, therefore, boiling point is less in tertiary amines than primary and secondary amines. Hence, the order of boiling point will be primary amines will be having, then secondary amine, and then tertiary amine. Intermolecular hydrogen bonding in primary amines will take place in this way. So you can see here intermolecular, that is between two different molecules of amines. You have RNH2 here, another RNH2 here, another RNH2 here. So between the hydrogen and the nitrogen, there is an electronegativity difference. So there will be a hydrogen bond which is formed here. Hydrogen will have a partial positive charge, nitrogen will have a partial negative charge. Okay. Now moving on to the basic character of amine. So amines are basic in nature. Now why is that? Let us see. Like ammonia, amines are bases and react with mineral acids to form salts. Okay. So if a particular compound is able to react with an acid and form salt, means that that compound will be a base, right? Salt will be formed by the reaction between an acid and base. So ammonia is a base, we already know that. Same way, amines are also base which have the tendency to react with mineral acids like HCl, H2SO4, mineral acids, and it will form ammonium salts. Okay, that is why it is acting as a base. Right, this reaction shows that amines are basic in nature. Of course, it is forming a salt, right? Due to the presence of unshared pair of electrons or nitrogen atom, they act as Lewis bases also. What are Lewis bases? Those substances which have the tendency to donate electrons. And in ammonia, you have lone pair of electrons. Same way, in your amines also lone pair of electrons are still present there, right? So because of the presence of this lone pair of electrons, it acts as a Lewis base, right? Now based on pKb values, we can decide the basic strength of amines. Lesser the pKb value, stronger will be the basic strength. So Kb value is directly proportional to your basic strength. If Kb value is more, basic strength will be more. If pKb value is more, basic strength will be inverse to that. Okay, pKb value more means basic strength will be less. Okay, so you can see here, this is a primary amine, reacts with hydrogen halide, that is your alkyl halide. What happens? It takes up this hydrogen and forms RNH3X minus. It has the tendency to accept this hydrogen. So you can see here, this is a primary amine and a mineral acid, that is HX. It can be HCl, HBr, any mineral acid is taken. What is going to happen? This HX is taken up and what will happen? RNH3 and X minus will be formed. RNH3 plus and X minus, which is a salt. So if a salt is formed by reacting with an acid, means the compound which you have taken, your amine, must be a base, right? So you have aniline reacts with HCl, hydrochloric acid, which is a mineral acid. What you are going to get? NH3 plus Cl minus you are going to get, which is a salt. Clear? Now, variation of basic strength of amines in gaseous or gas phase medium. Let's see. So moving on to the next part, that is variation of basic strength of amines in gas phase medium. Among primary, secondary and tertiary aliphatic amines, the electron releasing effect is maximum in tertiary amines and minimum in primary amines. So what is this electron releasing effect? Electron releasing effect, your methyl groups or alkyl groups in general, they are electron donating groups, right? So primary amines means it is RNH2. You have only one alkyl group, only one electron donating group. In secondary amine, it is R2NH. You have two electron donating groups, and in tertiary, you have 3 electron donating groups, right? So in that way, if we consider electron releasing power will be more for which one? It will be tertiary, because there are 3 alkyl groups. Therefore, the basic strength is expected to increase from primary amine to tertiary amine. So tertiary amine will have the highest basicity because it is having 3 alkyl groups. All 3 are electron donating as well. The observed basic strength of methylamine, dimethylamine and trimethylamine has been found to follow the expected order in gaseous phase or in non-aqueous solvents like chlorobenzene. So tertiary amine will have the highest basic character, then secondary, then primary. That is R3N will have the highest because more electron donating groups are there, and R2NH and R NH2, right? More alkyl groups, more will be the electron donating character, hence more will be the basic character in gaseous medium. For example, trimethylamine, then dimethylamine, then methylamine. Clear? Now, which are the factors on which the basic strength of amine depends? Let us discuss. So, one is plus I effect, that is plus inductive effect. Another one is extent of hydration by hydrogen bond. That is how easily the hydrogen bond is being formed. And the next one is steric effect. So, first let us discuss plus I effect. Electron donating inductive effect increases the basic strength of amines by increasing the electron density on the nitrogen atom. Okay, so more alkyl groups are present means more will be the electron donating character. Okay, so more electron donation is taking place towards the nitrogen atom means the nitrogen atom becomes more electron dense. Hence, what happens? The basicity will increase. More electrons is there to donate means, of course, the amine is going to become more basic. More the methyl groups attached to the nitrogen atom, more is the plus I effect because more alkyl groups are there, right? And hence the basic strength of methylamines. Thus, based on plus I effect, the strength will be tertiary, secondary, primary. Because in tertiary, you have 3 alkyl groups. Right, 3 alkyl groups, and in secondary you have 2 alkyl groups, and in primary you have 1 alkyl group. So more alkyl group means more will be the electron donating character towards the nitrogen atom, hence it becomes more basic in nature. So that is regarding plus I effect. So according to plus I effect, the order of basicity will be tertiary, secondary, primary. Tertiary having the highest basic character. Now moving on to hydration effect. Basic strength of methylamines depend on the extent of hydration of methyl ammonium ions, which are formed by the protonation of amines. So the extent of hydration will be the order primary, secondary, tertiary. So let us take a primary amine first here. So here you can see OH2, OH2, OH2 means H2O, right? And here you have secondary, you have 2 methyl groups and R, NH is there. So you can see it is forming 2 hydrogen bonds and here only 1 hydrogen bond is formed. So 3 hydrogen bonds are formed in primary amine, in secondary only 2 are formed, in tertiary only 1 is formed. So according to that case, what we can see, the extent of hydration will be more in primary, then secondary, then tertiary. So in that way, primary will be more stable than secondary, than tertiary. Now the last one is steric effect. The basic strength of amines also depends on the ease with which the protonation of amines takes place. The presence of bulky alkyl groups hinder the protonation. This hindrance is called steric hindrance. More are the alkyl groups present in amines, more is the steric hindrance. Basic strength will be in the order primary, secondary, tertiary. Now according to this, that is the steric effect. Steric effect means alkyl, because of the presence of alkyl groups, it hinders the activity or the reaction of the particular compound. That means in primary you have only 1 alkyl group. In secondary you are having 2 alkyl groups and in tertiary you are having 3 alkyl groups. So this is a bulkier group because in all the nitrogen atom is combined with all alkyl groups. So in that case, bulkier will be the group and what happens? It will not help in the protonation. So that means that it will not help in the removal of the H plus ion. Hence the order will be primary, secondary, tertiary. So these are the 3 factors which includes the basic character of amines. Right. Now moving on to the important part of this basic character of amines. So here we are going to compare the basic character of alkyl amines and ammonia and aryl amines. So you have alkyl amines, you have ammonia which is NH3 and you have aryl amines. So we are going to see which is having the highest basic character, which is having the least character, whether it is alkyl amine, ammonia or aryl amine. So let us see. First we are going to compare alkyl amine and ammonia. Alkyl amine means from ammonia the hydrogen is being replaced by alkyl groups. Okay. So alkyl amines are stronger bases than ammonia. So comparing ammonia and alkyl ammonia, that is replaced by alkyl group, which is more basic? It is alkyl amine. Let's see why. This is due to the electron releasing inductive effect of alkyl groups. So ammonia means you just have NH3, right? You can see here NH3. This is ammonia. So it forms NH4 plus. Okay, it forms NH4 plus, which is ammonium ion. Now, in case of alkyl amine, one extra person is there. That means one hydrogen is being replaced by an alkyl group. And this alkyl group has the tendency to donate electrons. So, as we have already discussed, when it is electron donating, what happens? The basicity increases, the basic character increases. Hence, what is formed here? The particular ion is formed here. And what it is? More electron donating character is there, means, of course, the basic character will be more. In ammonia, there is no alkyl groups compared to alkyl amines. So, their extra alkyl group is present, electron donating, more basic character. Right. Now, alkyl groups by their electron releasing effect increases the electron density on nitrogen and hence make the lone pair of nitrogen more easily available for sharing with proton. Right, lone pair of electrons must be available for the proton so that protonation will take place. The H plus will be accepted and the ion will be formed. Right. So, in case of ammonia, there are no alkyl groups. So, the ions will be formed. Okay, NH4 plus will be formed, but still it will be more easily formed in the case of alkyl amines because the lone pair will be more available because of the electron donating nature of the alkyl group. Now, moreover, electron releasing effect of alkyl groups stabilizes the alkyl ammonium ion formed from amine due to the dispersal of positive charge by plus psi effect. For example, methylamine is more basic than ammonia. This is because methyl group is electron donating. Methyl group is an alkyl group, right? It is electron donating and increases the electron density on nitrogen atom. This makes the lone pair of electron on nitrogen more easily available for the protonation. So, what you have to remember, comparing alkyl amine and ammonia, because of the presence of that extra R, which is electron donating group, the lone pair of electrons in nitrogen will be more available for the protonation. Clear? So, that is why comparing alkyl amine and ammonia, alkyl amines are more basic. Now, we are going to compare aryl amines and ammonia. So, let's see. Aniline. Aniline means what? It is an aryl amine itself, right? What was aniline? On benzene, you have NH2 amino group. So, this is called as aniline. Aniline is less basic than ammonia. Now, this is because phenyl group of aniline exerts minus I effect. Okay, it exerts minus I effect due to resonance. So, in aryl amines, what is one extra thing which is happening? A resonance will take place. So, because of this resonance which is happening there, minus I effect will be there and resonance will take place. Because of that, the basicity will be less than that of ammonia. This results to the lower availability of electrons on nitrogen for protonation. In case of alkyl amines, the electrons were more available because it is an electron donating group. But in case of aryl amines, due to the resonance which is taking place, the resonance structures you can see here, because of the resonance which is taking place, the electrons will be less available. Right? Because if it is less available, what happens? The reaction will be slow. So, because of that, the nitrogen will not be much available for protonation. In aniline or other aryl amines, the NH2 group, that is amino group, is attached directly to the benzene ring. It results in the unshared electron pair on nitrogen atom to be in conjugation with the benzene ring and thus making unshared electron pair less available for protonation. So, you can see here, this is the structure of aniline. You can see here, there is a lone pair of electrons in nitrogen, which is under resonance in this case. So, you can see here, the electron is shifted as the double bond and it gets a positive charge here because the nitrogen lost the electron. Now, this bonds become a charge here and the bond becomes a charge here. Now, the charge becomes bond here and bond becomes charge here. Now, charge becomes bond here, bond becomes charge here and the charge goes back here to become a bond and it will give the first structure itself of that aniline. So, you can see here 5 structures, 5 resonance structures of aniline is present here. So, because of this, what is happening? Because this lone pair of electrons is not freely available now. It is a part of this resonance which is taking place. So, of course, what will happen? The basic character will be less. I hope it is clear. Now, comparing the resonance structure of aniline with that of anilinium ion. On the other hand, anilinium ion obtained by accepting a proton can have only 2 resonating structures. So, this is aniline's resonating structures. You have 5 structures. So, basic character will be less and this will be more stable. More resonating structures means more stable. But if aniline accepts one more proton, then NH2 becomes what? NH3 plus it will become. That is your anilinium ion. Now, anilinium ion can have only 2 resonating structures. That is just by the shifting of this double bonds. Other than that, there is no electrons which can take part in this resonance, right? Only the double bonds will be shifted. So, only two resonating structures are present here. Greater the number of resonating structure, greater will be the stability. We already know that. Thus, aniline has 5 resonating structure. You can see it is having 5 resonating structure, is more stable than allylium ion, which is having only 2 resonating structure. Hence, the proton acceptability or the basic nature of aniline or other aromatic amines would be less than that of ammonia. Okay, so more stable means they are not ready to give its electron. They are happy like that. They are already stable. So in that case, what happens? The basic character of aniline will be less than that of ammonia. So comparing all these 3, aryl amines will be having the least basicity, right? And then you have your ammonia, and then you have alkyl amines. So I hope the reason is clear for you. In alkyl amines, electron donating groups are there. This is your alkyl group. In ammonia, there are no alkyl groups present. In aryl amines, why it is less basic? Because there is a resonance taking place, and because of that it is more stable. I hope it is clear. So in the next session, we are going to discuss about the chemical properties of amines. So I hope the concepts that I've covered in this session is clear for you. So that's all for today. Thank you.